particular problem deals with something called Hess's law. And in this kind of problem, you'll be given information about different reactions. And the question will be, what is the value of delta H reaction for a separate reaction? And the idea is that we use these three reactions to add up to the reaction down here. This one says, please show all of your work, including writing out all of the reactions and showing how they add up to the reaction that is the answer, just like we did in lecture. I guess there should be a closed parenthesis there. And so basically what we're trying to do is we're trying to create this bottom reaction out of the reactions that are up top here. And my approach to doing this is whenever I see, so I have three reactions, and let's say I see oxygen. Oxygen is in two different reactions, and H2O is only in one. Sulfur dioxide is only in one of them. And so what I really want to do is I really want to zone in on the things that are only in one reaction. So the sulfur dioxide is only in one, the hydrogen sulfide is only in one, and it looks like the water is only in one as well. And what I want to do is I want to take these reactions up top here and make them match the reaction down here. And what I mean by that is, so I'm going to start with the H2S. And for H2S, hydrogen sulfide, so I see that H2S is a product here, and it has a 1 coefficient. So in order to make this reaction match the reaction down here, I have to do two things to it. First, I have to multiply everything times 2 here. And so that's going to be 2, 2, and 2. And when I multiply everything times 2 for the coefficients, I also multiply the delta H reaction times 2. And the way that we can think about this is if twice as many moles of this reaction occur, then there will be twice as big a change in the delta H of reaction for the process. That's fine. So now I have a 2H2S and I have a 2H2S down here. But then this is on the product side and this is on the reactant side. So I now have to flip the reaction. And actually, I'll write that in red. So flip reaction. And what I mean by flip the reaction is change the reactants into products and the products into reactants. But when I flip a reaction, I have to take the minus sign of the delta H. So now I will write this reaction down here, flipped, so 2H2S, gas, goes to now my reactants are going to be products. And I will write my delta H as minus 2 times the value that's here. So delta H reaction for this that I've just written is, and let me get my calculator. So 20.6 minus times 2 minus, and I get 41.2 kilojoules per mole. Okay. Now, let's go back to another one now. And the one that I'm going to go to is, I guess I could go to either of these, but I'm going to go to this top one. And for this top one, I can see that sulfur dioxide is already a product. So I'm not going to have to flip it. But it has a 2 down here in the reaction I'm trying to create. So I'm going to have to do the same thing. I'm going to have to multiply everything times 2. And multiply the delta H reaction times 2 as well. And when I write this down here, it's going to be, and I like to line up the arrows. So it's going to have 2 sulfur solid plus 2 oxygen gases goes to 2 sulfur dioxide. And then I'll write here delta H reaction equals 2 times this number up here, 296.8 times 2. And I have to say that one of my problem-solving techniques is, there's a little piece of dirt there, that's not a minus sign. I actually like to do all my math as positive numbers, and then I remember to insert the minus sign myself. I know it's, as with calculators, and so often happens, make sure you feel comfortable doing, getting your answer. Because you can also put in a minus sign at the end too. All right, jump in any time with questions, but not seeing any so far. Now I'm going to do my third reaction. For my third reaction, I've got 2 H2O liquid, and so I've got 1 H2O liquid. So I'm going to do 2 times everything, and this is going to be 2 times a half, so that's just going to end up being 1. And now I've got 2 on that side, and 2 times delta H as well. So let's see, and I have not paid attention at all to my hydrogen, and I have not paid attention at all to my oxygen, but the way these problems typically work and the way we set them up is that they will all work out. And I've got my fingers crossed here so you can see, because sometimes when I do this it doesn't, but let's see what happens. So now I'm going to write this reaction with my arrow lined up. I have 2H2, oh yeah, that's the right one, 2H2 gas plus 2 times a half is just 1, so that's just going to be O2 gas, goes to 2H2O liquid. And now I'm going to write 2 times 285.8. I get minus 571.6, where again I put in the minus sign by remembering which the sign is. All right, so now comes the magic time. If I've done it correctly, I will add up all 3 of these reactions to look like the reaction that I have in question. I can see that I have 2 H2s on the reactant side and 2 H2s on the product side, so I'm going to go ahead and cancel those out. I have, anything else cancel out? Oh, my 2 sulfur solids, again on the product side and the reactant side. And I don't think anything else is going to cancel out. So now I write what's left. 2 H2S plus 3 oxygens. Ooh. Oh, thank you. Sorry about that. And a question. So why do we have a negative sign for the second problem? Do you mean second reaction?
Yes.
Yeah, thank you. So for the second reaction, so this one has a minus sign, and we just have 2 times it. So like all we did was we multiplied everything times 2. So we just left the minus sign there and multiplied it times 2. For the one that we flipped though, it was different because it was negative, and when you flip a reaction, you have to take the negative of delta H. So this one is positive because we flipped the reaction. So if you don't flip it, if you just leave it how it is, then the sign should still be the same. Hopefully that answers your question.
Yes.
Okay, good.
I have a question.
Monique, go ahead.
Yeah, that means on this type of reaction, do we flip only one equation? I don't understand. Which one do we have to, do we going to know we should flip it?
Good question, Monique. So what's, for better or worse, all of these problems are different, but they all have the same idea. So the way that we know that we had to flip this reaction is because in the reactions that you're given, and in the reactions that you know the delta H of reactions for, you can see that H2S is a product, And in the reaction you're trying to create, H2S is a reactant. So the only way to get H2S from the product to the reactant side is to flip the reaction. So the way you know how to flip or not is based on where the chemicals are, or the compounds, in up here versus where they are in the reaction you're trying to create. So there is no set, we never know which one we have to flip or which one we have to multiply times 2 until we go through the process. And so that's why for this problem and a bunch of problems this chapter, it's important to practice multiple problems. And that's why you'll see at least 2 or 3 of these in the lecture outline. And we'll do one here. And even if you get one of these correct, which is great, you can work other ones to get more practice. And remember, as many problems as you work on the homework, as long as you get one of them correct, you will get credit, because I always take the highest attempt that you do. So there's no penalty for trying more problems and not getting them right. I mean, hopefully you'll practice and you'll get more right, but even if you don't, there's no penalty. Okay? But I can, yeah. So these are, these problems are sort of like puzzles, and that's why there's no set answer as to how you do it. And what we can do though is, if you want to, we can work a second problem of this so I can show you more of it. Just let me know after I finish this one. If you want to see another one, we can totally do that.
Thank you.
Yeah, sure. Okay, so where was I? So we got my H2S. Now I have 2 plus 1 oxygen. So now I have 3 oxygens. And because they're both on the reactant side, they add. The only time they cancel is when one's on the reactant side, like here, and the same thing is on the product side. Then we see that the things here in the first reaction both canceled out, but the things in the second and third reaction don't. And I'm just going to write them the same as they are here. It doesn't really matter what order you do, as long as you can see that they are the same. 2, SO2, yes, there we go. And the last step, and the answer that we're looking for, is that when you add reactions, you also add their delta H values. And so we're going to add 41.2 plus this negative number plus this negative number. So really we're subtracting them. And we'll get the delta H reaction for this bottom reaction, which is the whole point. And I will zoom out a little bit so we can get all of this on camera. There we go. Hopefully it'll stay in focus. And so now my last thing is to add up these 3 numbers. And to do that, I'm going to do 41.2 minus 593.6 minus 571.6. And I get minus 1,124 kilojoules per mole. And so that is the complete answer for this question. And the beautiful thing about Hess's law is that if you know some reactions and their delta H values, you can find the delta H for a different reaction. And I know this is a very chemistry example, but this same process is how things like how you might determine the delta H reaction for a biological reaction. Say in the Krebs cycle. So you could do a similar process for biological reactions, where some of the reactions we know the delta H values and we can do them in the lab, but some of them we can't. And so this does have biology applications, just to let you know one of the reasons we're doing this. Of course, it has chemistry applications as well, and they do this a lot in the petrochemical industry, the oil industry, when they're trying to find delta H reaction for different carbon and oxygen and hydrogen containing compounds. Anyway, I'm going to stop the video there. And so that'll be one.